In this video, we're going to get started on a new reverse engineering series, taking a look at a scanned brake lever and reverse engineering it a couple of different ways in Fusion 360, so stay tuned. Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to kick off a new series where we're going to be looking at reverse engineering this complex part. Now, there's a lot to unpack here, and full disclosure, I've actually recorded this thing 3 different times so far, and I wasn't happy with the way the model was progressing. So I've completely switched it up, and what I'm going to be doing in this series is talking about the basics of reverse engineering in Fusion. We're going to talk about the differences between a modified or a remeshed version of scan data. We're going to take a look at how to create the mesh section sketches and what some of the settings will do. And then we're going to talk about a couple of different methods. We're going to look at the difference between freeform reverse engineering this and also using prismatic modeling to get an approximate version of this. And then we're going to also be looking at trying to do this with traditional mesh section sketches where you would typically go if you're trying to reverse engineer a part. So there's also something that we need to make sure that we understand. There are pieces of software out there specifically designed for this. They're meant to take in mesh data and they are meant to help you reverse engineer it. Now, that doesn't mean that you're going to get parametric feature history based part. It just simply means that you can take that mesh scan data, you can start to build out a BREP or a NURB surface off of it, and then you can look at things like color maps to figure out if you're high or low depending on the original mesh. So Fusion is not that software, but it does have tools that do allow us to do this kind of work, reverse engineering. So if you're using Fusion and you're kind of on the fence about whether or not you need to go to a software like Geomagic, well, hopefully this video series will help you understand how to reverse engineer these parts and whether or not you even want to do that at all. So to follow along, if you want to, in each video, I'll be putting a link in the description for the data set where it is at that point in time. So right now you can go there and download this file here, which has the mesh already in it. I'm not going to be talking about the scanning process. We actually scanned this part in one of the previous series where we were looking at the scan to part series. And so there's really no need for us to go into it again. If you want to see that, you can go ahead and click on the card, which will take you back to that series, and you can follow along with how we scanned this part. It was done with a provided scanner from Shining 3D, a Pro HD scanner. We used a turntable and a tripod, a fixed scan method. So again, if you want to check that out, go ahead and go to that video series, and that'll talk more about the surface prep and how we scanned it and how we process a mesh. For this video series, we're going to get started in this first video specifically talking about mesh section sketches, and we're going to talk about some of the nuances for things that we need to understand. So I think that's a lot of talking. Let's go ahead and dive right in and get started. So the first thing we need to talk about is the mesh itself. Now in the timeline, we've got a feature here called Mesh Remesh. Now if we roll this back, we can see the mesh that I brought in. Now the mesh that I brought in is not the raw scan data. Now, in the scanning series, I always talked about leaving the raw mesh data, the raw scan data. In this case, I ended up using one of the higher smoothing levels, and the reason for that is because this is a well-used cast part. It doesn't have perfect features, it doesn't have prismatic fillets on the corners, and leaving it in the raw version really wasn't going to help me much. So I did bring it in. It was smoothed out in the Einscan Pro software, and it was remeshed here. And the main reason for that is we're going to talk about whether or not we even want to remesh it. To understand whether or not that is appropriate, let's first get into mesh section sketches. Now, mesh section sketches are a way in which we can gather data off of the scan. It doesn't have to be a scan, it can be just a mesh file that you bring in. But this is the main way in which we are going to get information off of this. So to get started, we want to go to our mesh tools and select Create Mesh Section. For this first example, we're just going to select the body and say OK wherever it's putting that plane. And it's kind of going to be somewhere in the middle of the body. I'm going to hide the mesh. And the way that we work with this is we're going to double click or right click and edit the sketch. So once we have a mesh section, what we need to do is go to Create, Fit Curves to Mesh Section, and we need to use this to fit it. But here is the trick of this. There are a couple different fit types we have. We've got splines, we've got a closed spline, circles and ellipses, lines and arcs. If we use any of these options, we need to be aware what we're getting out of it. Right now, everything looks really smooth or relatively smooth, but remember that we are dealing with a bunch of flat triangles. And with those flat triangles, there are going to be highs and lows. This is not going to be a nice smooth curve. So when we have a fit tolerance of 0.01, it's going to be pretty close to what we have here, which is a bunch of flats and a bunch of waves in the surface. So what we're going to do is we're going to take a look at a couple of different tolerance values. So 0.01, for example, we'll click here. And then we are going to do this at a sort of the opposite end of the spectrum. I'm going to say 1 millimeter, and I'm going to click it again. Now the reason for this is because now we can kind of see the highs and lows. So hiding that mesh section, this is plus or minus a millimeter. This is plus or minus 0.01. Now, why would we do this? Why would we even go into the process of playing around with these values? Well, when we show the curvature combs, this is where things start to get really ugly. So you can see there are a lot of spikes on this. And these spikes are pretty much any time the spline that was fit to that mesh section, anytime that goes above and below the mesh section, this is where we're going to see these spikes. So if I bring the mesh section back and we zoom in, it's going to be pretty hard to see on this one. Let's do it on the plus or minus 1 millimeter. This will be a little bit more apparent. So if I bring the mesh section back, we can see here this sort of sharp point is right where we're crossing over that section. We can see it here as well. We're crossing over the mesh section and we get that spike in the curvature. So essentially what's happening is we're going to get a bunch of these highs and lows, and really what we want out of this is a nice smooth transition, and this is just not going to give it to us. Now this one was the plus or minus 1 millimeter. The version that's plus or minus 0.1 is going to be, again, it's problematic because it's got a lot of these spikes. Now, does this matter in terms of the part that we're creating? Yes, 100% it matters, because downstream, you're going to have surface imperfections or quality issues, especially once we start to take this and try to do things like loft between a prismatic shape. If we have an extrude with fillets on the corners and we try to loft between this and that, all these little irregularities in the surface are going to start to come out. Because of that, we need to be extremely careful when we're creating these mesh sections and using these tools and these tolerances. So what I'm going to do is delete this mesh section, delete the sketch. I'm actually going to delete the remesh and go back to the original, and then we're going to repeat that process again. We're going to create a new one, then we're going to edit this sketch and follow the same exact procedure. Another thing that you can do to kind of speed this up is the S key on the keyboard is a shortcut. And if you say fit mesh curves and you use a little up arrow, which will show here, you can put it on the shortcut menu, which just pops up wherever the key, the mouse is. And that way it just speeds it up a little bit. So again, you can see here, plus or minus a millimeter is kind of way too much. If we do plus or minus 0.04, that was the resolution of the scan. And I click that and say, okay. Let's go ahead and take a look at the differences between these two. So again, plus or minus 1, that actually looks pretty good. It looks better than it did on the remeshed version of the scan. It still has these spikes in the corners. Those happen exactly where the fillets are, or where the fillets would be if this was a prismatic part, but everything else is relatively smooth. If I take a look at the plus or minus 0.04 version, this is better than it was on the remeshed version, but it's not like crazy wildly better. It's not like close to perfect by any means. It's just better than worse. And this is not by any means a fault of the tool. It's doing exactly what we're asking it to do. We're fitting a curve based on those tolerances, and it's only going to be as good as the mesh that we're bringing in. So that brings me to the point of the mesh. Do we want to remesh? No, not really. We generally, if we're trying to get these curves, generally what we're going to be doing is bringing in a very high density mesh. And this is awful for performance. This mesh it's a pretty small part, so it's not that big of a deal. But if you are bringing in a gigantic mesh with a ton, millions of triangles, then you're going to start to see performance issues. Here, it's not really making much of a difference, but in general, it would. The other thing that we can do is start to play around with these tolerances and figure out where a good solution is. So you can see plus or minus a quarter millimeter, not exactly fitting to that underlying mesh section, but if we take a look at the curvature map, it's starting to get better. We're not seeing as many spikes in the curvature. We are still seeing issues, these sort of inflection points. And unfortunately, downstream, it's just going to be problematic for us in terms of the curvature. So, with all of that said, what should you be looking for if you're trying to do this kind of reverse engineering and this kind of modeling? Well, again, it's going to come down to a fairly high resolution, a high triangle count mesh, and it's only going to be as good as whatever you scanned. So again, this is a cast part. So if we rotate this around, there is essentially a flat section here where the casting was ground. So we're never going to get a perfect solution there. And this was a used part, so it's going to have some wear in the corners, and it also had some, there was some grease and stuff. I didn't clean this part off when I scanned it. So, it's not perfect to start with, and it's not going to get any better. It's not like using things like Remesh are going to magically give us a better result. It only can work with what we have. So for example, if we look at this corner right here and the way that the light and the shadow is, you can see that it's sort of consistent with here somewhat, and then it gets pinched down a bit. It gets a little bit thinner. And those inconsistencies are going to come through when we start doing mesh sections. It's not like they're going to magically go away. And changing that tolerance value isn't really going to help that, because we're going to end up losing some of that resolution in the corner. So one possible solution is to do this with a bunch of smaller splines, but the problem is it's not going to get any better than it is. It's not really, unfortunately, it's just going to be what it is. So because of that, if you're trying to replicate this part exactly, then this might be a perfectly valid option. You can use these mesh sections, and it's going to pick up all of the imperfections, and it's going to pick up all of that. And that's perfectly fine if you're just trying to recreate this part. However, if you're just trying to recreate this part and all of its imperfections, if the end goal is 3D printing, or if you're trying to build a mold for it off of a 3D print, then why even bother? Just clean up the mesh a little bit, make sure that the holes are the right size, and just use it as is. If you're trying to make a part that you can manufacture, let's say machine, then you kind of have to look at the design that you have versus the design intent. Was this part extruded? Was this part lofted? How were the corners created? Is this a consistent fillet and then it kind of flares out here? All of those different things need to come into play. So a part like this, if I get started trying to reverse engineer this infusion, my first step is, what do I want to do with it downstream? Is this just an exercise for me to practice? If so, then I don't really care as much. Is this an exercise where the downstream effect is I need to CNC machine this thing or potentially machine the mold for it? If that's the case, then things like these rounded corners here, those are going to be machined with a ball end mill, or potentially a pencil mill or a lollipop or something like that, where I have a consistent radius value that I need to hit. So that means I need this to be a perfect fillet, and that's just going to be the case. And by the look of it, that fillet carries onto this edge and carries down. Maybe it increases in size, but for the most part, that is a consistent radius. I do Control and 4 to hide the edges. So I would need to pay a lot of attention to where these edges are and how all these edges are coming together in order to create that fillet. Again, this is a cast part and there are imperfections in it. So we're going to have to kind of make some concessions about what we want to see here. But, overall, those are the things that I'm kind of looking at. Do I need to machine it? Do I need to 3D print it? What do I need to do with it downstream? And that's going to determine the path that we go. So this video is all about the mesh section sketches and using those to essentially start to build out the model. So what we're going to do is we're going to carry on and we're going to build out essentially the middle of this. Not the entire thing because it's going to take more than just a loft to get it. But what we're going to do is we're going to build out the middle of this using those mesh section sketches. So this brings me to the next tip that I want to share here, and that is don't waste your time creating a ton of planes. You're going to need planes in order to do the mesh sections, but the quick way for us to do this is just create a sketch. I'm going to do this on the top plane, and essentially what I want to do is just create a bunch of lines. Now the lines need to be essentially cutting straight through the part. We want to make sure that we're as close to normal to the curvature as possible. Now you want to put as few lines as possible here, but it's tricky because this part actually starts to get bigger right here, so we need to capture that. And it actually gets kind of smaller down here, but because of that transition into the ball that's on the end, we're just not able to capture that. So you're going to have to put a decent number of these lines in, unfortunately, but try to get them close to cutting through at a normal angle. So basically, if you think about this as being a straight line, you want that to be 90 degrees going through. It's going to be tricky in the corner, so we're going to have to probably make a couple here. And generally, if we're doing this method, if we're going to use lofting to go through these different sections, we're not going to have any guide curves. There will be no guide rails because all it's going to do is make this geometry pretty bad. Since we know that we have this reference here, lofting through this many sections is probably going to be fine. Like the geometry we get is probably okay, but you do still need to be kind of very careful about it. So I'm going to come over here fairly far. Again, we're not going to do the entire thing, but I can always cut some of this away. It's kind of a little bit harder for me to add more back. There's also casting marks on the bottom. I'm going to use Control and 4 to hide the edges, maybe make this a little bit easier to see. So I want to avoid these dimples, so potentially just pull some of these edges over. If this one is too close, actually I might just delete that one altogether and just pull this one closer, pull that one a little closer. And we can kind of see the lighting, the highlights from the shadows and the lighting get kind of wide here and narrow up, and they get narrow here. These are all things that are going to be problematic to us. This one is tricky because it's right in that corner, and we're not going to be able to get anything useful out of there, so I'm just going to delete that last one and just call it good at that. So when we finish the sketch, the way that I'm going to do this is just extrude a bunch of surfaces. Now, these surfaces are going to be the selections for my planes. So we'll say OK. And to clean this up a little bit, I'm going to create a new group in the bodies folder, select all of these bodies, move to group, and then just put them all in here. Now the benefit here is that I can hide and show them all at the same time. I also like to use A on the keyboard for appearance. I'm going to be using some plastic appearances. I'm going to turn all of that green and then give the lever itself like a white color or just something that's a little bit easier to see. So if green doesn't work, we can make it red and just keep the lever something that's a little bit easier for us to see. Control 6 to bring the edges back. All right, so now at this stage, we have everything we need to start building the mesh sections. This process, unfortunately, is kind of painful. It's going to take a while, but basically go to Mesh and create Mesh Section Sketch. So what I'm going to do is I'm going to pull this over to the right. You can also undock this if you want to make it a bit easier. I leave mine docked in the default location. Just kind of when making videos, it makes a lot more sense to just leave it where it is. So what I'm going to do is select this mesh. We can't tab to this next box for whatever reason in Fusion. Tab works between numerical inputs, so I can tab between these three, but you can't tab between the selection dialogues. It's kind of a little frustrating, but knowing that you can't do that, just pull the design close to the dialogue or the dialogue over. Right click to say OK, right click to repeat, select the body, select the next one in the line, OK, right click to repeat, body, next one here, and then 3 o'clock position to OK, 12 o'clock to repeat. And you just got to keep doing this. It's just a time-consuming operation, unfortunately, and there's not really a shortcut to it. I mean, maybe there's some automation that you could bring in. You could create a small script or something to do this, but you know, honestly, this is not the way that I would reverse engineer this part. It's just not it's not a great solution. We're going to see that a little bit. As I mentioned, I already recorded this a couple times, and I was not really happy with the results. So that's why I'm sort of changing up what these videos are going to be. But we'll get to that in a little bit. Probably in the next video, we'll talk about lofting between these. But let's go ahead and select this. Another one here. Just kind of move through them. It can be kind of tricky to see if you are getting all the curves. So every once in a while, you can think about changing the color or zooming in. You can also use Control and 4 to hide the edges. When you have a mesh, those edges really make a huge difference just visually. So doing this by hiding the edges can be a little bit quicker. And one more to go. Right click, repeat, select the mesh, and there we go. So now we have all these. I can hide the group, and we can see all of the different sections here. So that looks pretty good. It seems very promising. But unfortunately, the second part of this process is that we now need to turn each one of these into an actual curve that we can use. So that means editing the sketch. Again, S key, if you can add fit curves to mesh section, this will help. And the reason this will help, and this might seem kind of silly, but when you do this kind of work or design work for clients, you know, if this is your job, moving the cursor up here to click here, to move down here, then to go back over here, doing that dozens of times does add quite a bit of time to the process. Now I'm gonna kick this down to 0.05. Click on that, say OK. This is going to be underdefined, so I'm going to lock it or fix it. Right click and say OK and finish sketch. We don't need to fix all of them. You can if you want to. It's going to add to the amount of time this takes, but otherwise you will be able to sort of freely pull them. So I'm going to carry on doing this. It's the same process. Just click it. It'll remember the tolerance. We can right click to OK, finish the sketch. And I like to, each time I do this, I like to go in and expand this and hide the mesh section. It just kind of helps me visually. And then also we can see this one's underdefined because I didn't fix it. It just kind of gives me a cue as to the next one that I need to do. Again, right click to OK, finish, and move on. Because this is just a very, you know, there's a lot of repetition in this process. I'm going to go ahead and speed this part up. And you guys carry on your side, creating these curves for each one of these. All right, so now we have all of these sections. Again, it's just a time-consuming process. It only really takes a couple minutes, but it's a lot of just repetition. Probably a good time to do a save just so we don't lose anything. And honestly, I was going to do a second video talking about lofting, but it's pretty easy, so I'm just going to go ahead and cover it here. We'll go to Create, Loft. You can do this as a solid or surface. It's not going to matter for the geometry really, but we're just going to go through and begin clicking each of these sections. Now, if you're doing a solid loft, you will need a closed profile. Surface loft doesn't need that. You'll be selecting the actual curve. But the other thing that we want to be aware of are these dots, the ones on each profile. Now, these dots are going to represent where a seam is going to go. And that seam is pretty important. It's not just a visual thing. It will have an effect on the surface. So if I start pulling these dots around, you can see that this fails. That's because what it's trying to do is twist between them. So I like to put these, at least in this design, on the back side. And these little things are always in the way. But I like to put them on the back side and then basically go through and just start manipulating them so that they're nice and smooth. So we're going to pull this one around the back and this one as well. It's going to fail until we fix all of them. And then what we're going to do is you're going to realize as you start to do this that their position makes more of a difference than you probably probably anticipate, because it's going to affect the curvature, and you can just within a millimeter, you can make a big difference in the final outcome of the solid or surface. So unfortunately, when you don't have a start and an end point on a curve, Fusion does a pretty good job of trying to make this work without needing your input, but it does still affect it. So you do need to come in and sort of make these adjustments. Let's go ahead and pull this one over. Now, because there is a live preview on Loft, it gets a little bit messy. It does kind of hang up because you can't, as far as I know, you can't toggle off the preview for this operation. Some operations, some things you can toggle on a preview. So like with mesh tools, you can preview what's happening. With the Loft tools, you just are kind of stuck waiting for it to update. And because what we're doing is essentially breaking the Loft, it's just not working. Another thing that you can do is you can try, let's go ahead and just clear all these out. You can try to select in a certain area, but you'll notice that with the closed profile, that doesn't even really matter. Now, if I try to add this profile in, it's going to kind of lose its mind because it needs to be up higher. So what we can do is we can sort of restructure that. So profile 15, I think it should be like 4. Yeah. So I just need to make sure that they're kind of in order. All right, so from the side, for this one, I'm just going to leave the seam in the front. But what I want to do is I want to essentially get it to be somewhat straight or follow the shape of the thing that we're creating. So in this case, it'll start to come down a little bit, and this side will essentially be from here on to the end. This will essentially be a straight line. And as we're doing this, you'll start to notice the shading, the lighting, all of that is going to start changing. And until we straighten all these out, it's going to be pretty messy. So we'll get this one down. Now there is an analysis option in here. You can turn on zebra stripes, or actually the ISO curves can be pretty helpful. I am going to increase the number of ISO curves, and you can watch the way in which they're twisting. So you can kind of see this one twists and ends up here. If I pull this edge down and make some adjustments, we can kind of see changes that happen. Again, we can also turn on things like zebra stripes and get an idea where the curvature is going. For this, again, this is not the method I would do this, so I'm just going to accept it and say okay. But that's not horrible. I mean, that's not a bad result. It looks like it matches the mesh pretty well. And if we toggle on our curvature map analysis, what we would want to look for here in the principal max is we're going to drop this down, and we want to see where the red goes. Now we can see we're getting some sort of sections that are pulling away right there. The back actually looks really good. That is acceptable to me. The front here, where we kind of have these sections where it's pulling away, these are the problem areas. These are areas that I would not want to see. Overall, I mean, it's not a bad solution, but overall, I don't think it's a perfect solution, but it might be perfectly acceptable. It all comes down to what you need out of the model. Let's go ahead and save this before we talk about this anymore. All right, so now that we have this lofted piece here, as I mentioned, I'm going to do this over a couple different videos, but now that we have this lofted piece, that it looks pretty good. I mean, on the surface, everything looks to be pretty nice. But the problem that we have here is trying to connect or carry it out to all of these other prismatic features. So again, right now, if this thing had to be machined, then it would be more difficult than if we had designed it in sort of a prismatic nature. Because of that, carrying on and building these other features over here becomes tricky. Now, I have done it. As I said, I did record this. This is the 4th time going through. So at least 2 other times I've gone all the way through and built the model using this method with the loft. But as I mentioned, I just wasn't really happy with the results. I think for the time that you spend, I think there are better ways to get a good end result. So for this video, this is as far as I want to take this one. In the next video, what we're going to do is we're going to explore how to use freeform tools to begin building and designing this thing as well. And the plan is, after that video, what I want to do is I want to cover it designing this part, basically looking at the design intent, but designing it with prismatic features, doing extrudes, adding fillets to corners, and really trying to control it more like we wanted to machine it. So hopefully looking at these 3 different methods will give you a good idea as to maybe what's possible with Fusion and maybe a direction that you would want to go. But as I said, that's as far as I'm going to take this one. So for right now, make sure that you do save. And if you have any questions on this so far, talking about the mesh portion of it, the mesh section sketches, the tolerances, or whatever, please let me know. Leave a comment. And as always, thanks for watching. We'll see you in the next one.